Welcome to 15-Minute Discourse. Today we're diving deep into Dyson spheres. Those crazy megastructures dreamt up by physicist Freeman Dyson. We'll unpack what's important from the theoretical physics to the practical challenges of actually building something so enormous and explore what Dyson spheres might tell us about advanced civilizations out there.
It's really fascinating how Dyson spheres force us to redefine what's possible with engineering and technology. They make us confront our current limitations while envisioning the achievements of civilizations far beyond our own.
It's that jump into the realm of the almost impossible that makes this deep dive so thrilling. We're not just messing around with science fiction here, right? We're exploring real scientific concepts, bridging the gap between what we know now and what might be achievable in the future.
Exactly, and they might seem like they're straight out of Star Wars, but the principles behind Dyson spheres are actually rooted in the real laws of physics and thermodynamics. There's no magic, just the potential of applying scientific principles on a scale beyond anything we can currently grasp.
So let's break this down. What is a Dyson sphere?
At its core, a Dyson sphere is a hypothetical megastructure built around a star to harness a significant portion of its energy output. It was first proposed by physicist Freeman Dyson back in 1960, but the concept has evolved quite a bit since then. Dyson initially imagined a solid shell completely surrounding the star, but as we'll see, that design poses some pretty big challenges.
Challenges so big they make a solid Dyson shell impossible.
You got it. The Dyson Spheres PDF document and your notes highlight the immense strength and stability issues involved. Even with materials way stronger than anything we have now, a solid shell would buckle under its own weight and the intense gravitational forces.
That makes sense. So what are the more realistic types of Dyson spheres that scientists and engineers have come up with?
The most feasible type is the Dyson swarm. Instead of one rigid structure, a swarm is like a vast cloud of independent solar collectors, maybe satellites or even habitats, all orbiting the star in various configurations. This has numerous advantages over a solid shell.
So a Dyson swarm would be modular and adaptable, allowing construction to happen bit by bit over time.
You wouldn't need to get all the materials at once and build the whole thing in one go. You could start with a small number of collectors and add more as the civilization needs more energy. This also solves the material strength issue, because each individual component would be way smaller and easier to engineer.
But wouldn't managing the orbits of millions or billions of objects be incredibly complex, even for a super advanced civilization?
Absolutely. It's something your notes mentioned that the coordination and control needed to prevent collisions and keep the swarm stable would be mind-blowingly complex. It's crazy to even think about.
And how would energy even be transferred from these collectors back to the civilization?
That's another area where we'd need some serious technological breakthroughs. Wireless power transmission, maybe using highly focused beams of energy would be essential. But transmitting power on that scale, safely and efficiently, that's a major hurdle even with our current understanding of physics.
Okay, so a Dyson swarm, while more realistic, brings a whole new set of challenges. What about these other types of Dyson spheres mentioned in your notes, like the Dyson ring and the Dyson bubble?
A Dyson ring is basically a simplified swarm, a ring of collectors orbiting the star in a single plane. It's less ambitious and could be a starting point for a civilization. However, it captures far less energy and would probably need some sort of active stabilization to stay put over long periods.
And a Dyson bubble. That one sounds really cool.
Imagine a stationary shell of incredibly lightweight reflective statites held in place by the balance of the star's outward radiation pressure and its gravity. They'd act like a giant mirror reflecting some starlight and capturing some.
It sounds like it would need some crazy advancements in material science beyond anything we can do now.
You're absolutely right. The materials for these statites would have to be incredibly lightweight, but also super strong and reflective enough to withstand the intense heat and radiation from the star. We're nowhere near that with our current tech.
So it seems there's a whole spectrum of Dyson sphere ideas, from the crazy ambitious solid shell to the more realistic but still incredibly difficult swarm ring and bubble.
Yeah.
And the possibility of building each one depends on the civilization's technology.
Exactly. And that brings up a really important question. Why would a civilization even start something as colossal as a Dyson sphere? Obviously, they'd need a lot of energy, but is there more to it?
It's a question that gets to what we're trying to understand about advanced civilizations.
Right.
Their motivations, their capabilities, their long-term goals. That's where it gets really interesting.
Absolutely. Let's dive into those motivations and explore some of the more nuanced reasons why a civilization might decide to do something like this.
Let's do that.
Yeah.
But first, I think it's worth coming back to something you mentioned earlier about these concepts being grounded in real science. I mean, the scale of these structures is so mind-blowing that it's easy to get lost in the sci-fi of it all. But to really get why a civilization might try to build one, we need to understand the physics and engineering principles that make it possible.
Absolutely. We can't forget that even though we're dealing with these hypothetical megastructures, the underlying principles are based on solid laws of physics and thermodynamics. It's not magic or fantasy. It's about the potential of what we could achieve by applying scientific knowledge on a scale that dwarfs anything we've ever attempted.
So talk about those principles. What are the key concepts behind a Dyson sphere?
One of the most fundamental is the relationship between energy and surface area. A star like our sun emits an enormous amount of energy, most of which just radiates out into space unused. A Dyson sphere is all about capturing more of that energy by increasing the surface area available for collection.
So it's like building a giant solar panel around a star instead of just on a roof.
That's a good analogy. And the amount of energy you can collect is directly related to the surface area of your collector. So the bigger the Dyson sphere, the more energy you can theoretically capture.
Okay, that makes sense. What about the energy needs of these advanced civilizations? How much energy are we talking about, and what would they need it for?
The civilization's energy demands increase exponentially as it advances technologically. Think about our own civilization. We've gone from burning wood to harnessing electricity to exploring nuclear power, and each step has needed more and more energy.
And as our technology gets even better, especially in things like artificial intelligence, space exploration, and maybe even interstellar travel, the amount of energy we need will just keep skyrocketing.
Exactly. And that's why the concept of a Dyson sphere becomes more relevant as we think about civilizations thousands or even millions of years ahead of us. Their energy needs would be so huge that things like fossil fuels, nuclear fission, or even fusion might not be enough.
So a Dyson sphere could be a way for them to get the energy they need on a truly massive scale.
That's the main idea. But there could be other reasons, cultural, scientific, even spiritual reasons, that might push a civilization to build something so enormous.
I'm really curious about those other motivations, but before we get into that, I think we need to figure out how we would even detect a Dyson sphere. I mean, if they're out there, how would we know?
That's a great question, and it takes us into the world of observational astronomy and the search for technosignatures. Those are signs of advanced technology.
So what kind of technosignatures would a Dyson sphere give off that we could detect from Earth, or maybe with space telescopes?
The most obvious sign would be that the star gets dimmer. If a big chunk of the star's light is being blocked by a Dyson sphere, we would see a noticeable decrease in how bright it is. This would be especially true for a solid shell or a dense swarm, but more subtle for a sparse swarm or a bubble.
So we'd be looking for stars that look fainter than they should be, based on their size and type.
Exactly, but there's another clue. We would also expect to see a lot of infrared radiation coming from the Dyson sphere itself.
Why infrared?
Because even the best energy collection system is going to produce some waste heat. That heat would radiate away from the Dyson sphere, mainly as infrared radiation.
So a Dyson sphere would basically glow in infrared, even if we couldn't see it in visible light.
That's a good way to think about it. And the temperature of that infrared radiation would tell us about the size and efficiency of the Dyson sphere and the temperature of the star it's around.
Fascinating. So astronomers looking for Dyson spheres will be looking for stars that are dimmer than they should be in visible light, but way brighter in infrared.
Exactly. And there are other more subtle signs that researchers are looking into. For example, a Dyson swarm could cause irregular dips in the star's light as individual parts of the swarm pass in front of it. These transits would be much smaller than the transits of planets, but still potentially detectable with the right instruments.
So there are all these potential technosignatures that astronomers are on the lookout for. And as our telescopes and data analysis get better, our chances of finding those signs of advanced tech will increase.
Absolutely. And that's what makes the hunt for Dyson spheres so compelling. It's not just about finding alien megastructures, it's about pushing the boundaries of what we know and exploring what could be out there.
We've talked about what a Dyson sphere is, the different types that have been proposed, and the clues astronomers are looking for. Let's circle back to why someone would even build one of these colossal structures. You said energy collection is the most obvious reason, but there might be other more subtle factors at play. Can we talk about those a bit more?
Absolutely. Your notes and the Dyson Spheres PDF explore some really interesting alternative reasons. Let's consider a few possibilities.
This is where we go beyond the practical and start to think about the cultural and philosophical reasons behind a civilization that could build something like a Dyson sphere.
Exactly. Imagine a civilization that has mastered energy and can control the power of their star. What would they do next? What other goals might they have?
We've been talking about some pretty mind-blowing ideas about what a civilization might want to do if they could build a Dyson sphere. But I want to switch gears for a minute and talk about how these megastructures could tie into the search for extraterrestrial intelligence.
You mean the idea of finding aliens not by listening for signals, but by looking at how they might be changing their stars? That's a really cool aspect of this whole field. It's like searching for fingerprints on a cosmic scale.
Exactly. And what's different from traditional SETI, which mostly focuses on listening for radio signals, is that we'd be looking for the accidental signs of a civilization's tech, not intentional messages.
Right, and those accidental signs could be a lot easier to detect than any signal, especially over the huge distances between stars.
So how would that work? What would we actually be looking for?
Well, as we talked about earlier, Dyson sphere would create some very specific things we could see. The most obvious is a drop in the star's visible light.
Because the structure is blocking some of the starlight.
Exactly. How much the light dims would depend on how big and dense the Dyson sphere is. A solid shell would block the most light, obviously, then a dense swarm. A sparse swarm or a bubble would block less, but we could still see it with good enough instruments.
So we'd be looking for stars that are dimmer than they should be based on what kind of star they are and how far away they are.
That's the first step, and something our telescopes can already do. We
Yeah.
can measure how bright stars are incredibly accurately and compare that to what we expect based on what we know about stars.
So if a star is a lot dimmer than it should be, that could mean there's a Dyson sphere.
It's possible, but it's important to remember that there are other things in space that can make a star look dimmer. We have to be careful and not jump to conclusions.
What else would we look for besides the dimming?
The other big sign is extra-infrared radiation,
And that's because
any Dyson sphere, even a really efficient one, would give off some waste heat, and that heat would radiate away mostly as infrared light.
so even if we can't see the Dyson sphere directly, we might see its heat signature.
Exactly. And the temperature of that infrared radiation would give us hints about how big and efficient the Dyson sphere is and the temperature of the star.
So we'd look for stars that are dimmer than they should be in visible light,
Yeah.
but really bright in infrared.
That's the basic idea. The bigger the difference between the visible light and the infrared light, the more likely it is that we're seeing something unusual, like maybe a Dyson sphere.
That's fascinating. So astronomers looking for Dyson spheres are basically looking for stars that have a kind of infrared glow that doesn't match their visible light. But you mentioned other things in space can make a star dim or give off more infrared. What are some of those, and how do we tell them apart from a Dyson sphere?
That's the key question. Astronomers have been trying to figure that out for years. There are things out there that can look like what we're looking for. Things like clouds of dust around stars, binary stars where one star blocks the light from the other, and even some types of stars that change in brightness.
So how do we rule those out and know for sure we're not misinterpreting what we're seeing?
Well, each of those things has its own specific characteristics that make it different from a Dyson sphere. Like, dust clouds tend to emit infrared over a wider range of wavelengths than a Dyson sphere would. And binary stars would show a regular pattern of dimming as one star goes in front of the other.
So we have to really look closely at the data to see if it matches what we know about Dyson spheres and rule out anything else it could be.
Exactly. It's like being a detective. We need to gather all the evidence and put it together to see if it really points to a Dyson sphere or something else.
Let's talk about some of the searches that have been done for Dyson spheres. What are some of the big projects, and have they found anything?
One of the biggest searches used data from the WISE telescope. That's a space telescope that looked at the whole sky in infrared light.
So WISE was basically looking for stars with that infrared glow that could mean a Dyson sphere.
That was one of its main goals. And they did find some interesting stars, but none of them have been confirmed as Dyson spheres yet.
So the search continues. What else is going on?
Lots of things. Some projects are using radio telescopes to look for faint radio signals that might come from the machines of a Dyson sphere. Others are using optical telescopes to look for the dimming of stars that could be caused by a ring or a swarm.
It's pretty exciting to think that we might be close to finding evidence of an alien civilization that can build things that big. But it also makes me wonder, what are some of the biggest challenges in searching for Dyson spheres? What are some of the things that make it so hard?
One of the biggest problems is just how big space is. There are billions of stars just in our galaxy, and each one needs to be carefully checked for those tiny signs we've been talking about.
It sounds like looking for a needle in a haystack.
That's a good way to put it. And it's even harder because those needles might be super faint and difficult to see against the background noise of all the other stuff out there.
So we need really sensitive telescopes and really good ways of analyzing the data to even have a chance.
Exactly, and even with the best tools, we only have so much time to use them. There are tons of other things astronomers want to study, so it's hard to get time on the big telescopes.
So it's a tough competition for resources. But I guess finding a Dyson sphere would be so amazing that it's worth it. Now, we talked about different types of Dyson spheres. Would some be easier to find than others?
Definitely. A solid Dyson sphere would be the easiest to see because it blocks the most light and gives off the most infrared. But as we talked about, a solid sphere is also the least likely to exist because it would be so hard to build.
So what about swarms, bubbles, and rings?
A swarm would be harder to see because the individual parts would be smaller and more spread out. But we might be able to see the heat from the whole swarm or see little dips in the starlight as the parts pass in front of the star.
In a bubble, how easy would that be to find?
A bubble would probably be the hardest to find because it blocks the least light and gives off the least heat. But if the bubble is made of something really reflective, we might be able to see the reflected starlight, which would look a little different from the light coming directly from the star.
So each type of Dyson sphere presents its own challenges.
Exactly. That's why we need to come up with lots of different ways to search that are designed for each type of Dyson sphere. We need to think outside the box.
Now let's talk about what it would mean if we actually found a Dyson sphere. What would it mean for humanity if we knew for sure that there was another civilization out there that could build something that big?
That's a question people have been thinking about for a long time, and there's no easy answer. I think it depends on a lot of things, like what the Dyson sphere is like, how far away it is, and if we could talk to them.
But no matter what, it would be a huge discovery, right?
Absolutely. It would change how we see our place in the universe and make us realize that we're not alone. It would challenge our ideas about intelligence technology and the possibility of talking to other civilizations.
And it would probably lead to a whole bunch of new science and technology as we try to understand and maybe even contact those civilizations. But even if we don't talk to them, Dyson spheres, even as just ideas, have a lot of implications for science and technology. Studying them can help us understand our own universe and what's possible with advanced technology.
That's true. Dyson spheres are like a thought experiment. They make us think about things like the limits of materials, how to collect energy on a huge scale, and even the possibility of traveling to other stars.
And by thinking about those things, even just as ideas, we might come up with new solutions that could help our own civilization, even if we never build a Dyson sphere.
Exactly. For example, studying how the parts of a Dyson swarm move could give us new ideas about how to manage all the satellites around Earth so they don't crash into each other. And figuring out how to make the materials for a Dyson bubble could lead to new super light and reflective materials that could be used for all sorts of things, like better solar panels or spaceships.
So Dyson spheres are a way to explore the limits of what's possible and maybe even come up with new things that could really help humanity.
That's a great way to put it. It's one of the things I love about this field. It's not just about finding aliens. It's about expanding our own horizons and seeing what's out there. It's about challenging what we think we know and looking at the universe in new ways.
Let's talk about some of the ethical and philosophical implications of Dyson spheres. If they really exist, what does that tell us about the civilizations that built them? What can we guess about their values, their motivations, and their goals?
Those are some of the biggest questions that Dyson spheres raise, and I don't think there are any easy answers. We have to remember that any civilization that could build a Dyson sphere would probably be completely different from us. They would have a different history, culture, and values.
So we can't just assume they think the same way we do.
Exactly. We have to be open to the idea that their reasons for building a Dyson sphere might be totally different from anything we can think of. Our own history is full of cultures that see the world in very different ways, and it's probably even more different for a civilization that's millions of years ahead of us.
That makes sense. But we can still try to guess based on what we know about physics and technology and what advanced civilizations might need.
Of course. And I think one of the most likely reasons to build a Dyson sphere is just the need for more energy. As civilizations get more advanced, they need more energy, and eventually they might reach a point where their planet just can't provide enough.
So a Dyson sphere would be a way to solve that problem. But some people might say that a civilization that's willing to use that much energy and resources must be greedy. What do you think about that?
I think it's too simple to judge an alien civilization based on our own ideas. We don't know what they're really thinking or what they think about greed. Maybe they see it as necessary for survival, not as being greedy.
That's a good point. It's possible they see it as a natural way to grow and survive, not because they want too much stuff, but because they need to overcome their planet's limits.
Exactly. And it's also possible they have technology and ways of living that let them use energy and resources much more efficiently than we can even imagine. We might be looking at them the wrong way.
So instead of judging them, we
Hmm.
should try to learn from them. Let's talk about the Fermi paradox again. The fact that we haven't found any Dyson spheres yet seems to mean that advanced civilizations are either really rare or they don't last very long. What do you think about that?
It's a good question. And I think it shows that we need to think about all the things that could affect how long civilizations last and if they get advanced enough to build something like a Dyson sphere. It's not just about technology, it's about their society, their culture, and even biology.
What are some things that could stop a civilization from lasting long or from reaching the point where they could build a Dyson sphere?
There are a lot of things that could go wrong. First, a civilization needs to start on a planet that can support life, and even then, it has to avoid destroying itself through things like nuclear war, destroying the environment, or maybe even artificial intelligence getting out of control. Those are all very real possibilities, even for us.
Those are big hurdles. And even if they survive all that, they still need to learn how to build a Dyson sphere, which is way beyond anything we can do now.
It is, and it might be just too hard for most civilizations or that it would take too many resources. But there's another possibility. Maybe even if a civilization could build a Dyson sphere, they choose not to for some reason.
Why would they choose not to if they could?
There are a few reasons. Maybe they've found other ways to get energy that are better, easier, or fit with their beliefs. Or maybe they think it's too risky, like it could mess up their star system or hurt the environment. Or maybe they've decided not to advance their technology too much because they think it would be bad for their culture or their spirituality.
That's interesting, and it shows that it's not just about being able to build it. It's about what they choose to do. It's about their values, their ethics, and what they want for the future.
Exactly. And those choices would depend on their history, their culture, and how they see the universe.
Now, some people say that because we haven't found any Dyson spheres, it means we're alone in the universe,
Hmm.
that we're the only intelligent life. What do you think about that? Is it too early to say that?
I think it's way too early to say we're alone. The universe is huge, and we've only just started exploring it. Maybe we're looking in the wrong places, using the wrong methods, or maybe our instruments aren't good enough yet. Just because we haven't found something doesn't mean it's not there.
So there's still hope that we might find another civilization out there, maybe one that can build a Dyson sphere.
Absolutely. And even if we never find another civilization, just searching for them is valuable. It's pushing our knowledge, inspiring new ideas, and making us think about our place in the universe.
So searching for Dyson spheres is kind of a way of searching for ourselves, too, a way of understanding where we fit in and pushing our limits.
I think that's a great way to put it. It's about understanding what's possible and what it means for our future. It's about opening our minds and looking beyond our own planet to see what else is out there.
Now let's imagine for a minute. Some people have thought about some crazy ideas for how Dyson spheres could be used, like for traveling between stars or even time travel. What do you think about those ideas?
Those are some of the more far out ideas people have had. And while it's important to know what's theoretically possible versus what we could actually do, it's fun to think about the limits of what we can imagine.
So let's think about those limits for a second. How could a Dyson sphere theoretically be used for interstellar travel?
One of the craziest ideas is that a civilization could build a Dyson sphere around their star and then use the energy from the sphere to move the whole star system really fast. Like instead of building a spaceship, they would move their whole star.
That's mind-blowing. Moving a whole star system. How would they even do that? What kind of technology would they need?
It would be incredibly hard, requiring perfect control over insane amounts of energy. One idea is using the Dyson sphere to create a giant beam of energy that could push the star system. Another is to mess with the star's gravity to create a warp bubble that could make it move faster than light. But these are all just ideas, and we don't even know if they're possible, let alone if we could actually do them.
It's a wild idea to think about. And what about time travel? How could a Dyson sphere be used for that?
The idea of using a Dyson sphere for time travel is even more crazy than interstellar travel, but it's definitely captured people's imaginations. One theory is that the sphere's gravity could be used to create a wormhole, a theoretical tunnel through space and time. Another idea is that the sphere could be used to create something called a Tipler cylinder, which would allow time travel by spinning really, really fast.
So they could use a Dyson sphere to travel to the past or the future.
That's the idea. But remember, these are just ideas based on theories that haven't been proven. We don't know if they would work. And even if they did, time travel would create a whole bunch of ethical and practical problems.
It's definitely fun to think about, even if it's still science fiction for now. But let's talk about the future of Dyson sphere research. What are some of the most promising areas and what new discoveries can we expect in the next few years? What are you most excited about?
One of the most exciting things is that we're coming up with better ways to search for them. As our telescopes get better and we get better at analyzing data, we'll be able to find even the faintest signs of Dyson spheres. We'll be able to look at more stars and maybe find Dyson spheres that are farther away, weirder, or even ones we've already seen but didn't recognize.
So we'll be able to search more effectively and find things we might have missed before.
Exactly. And I think we'll also start looking for more than just dimming and infrared excess. For example, we might look for radio waves that could come from the machines of a Dyson sphere or gravitational waves that could be created by its movements. Those are all new possibilities that are opening up as our technology gets better.
It sounds like the search is getting more complex and more sophisticated. We're not just looking for one thing anymore.
That's right. And another good thing is that astronomers and computer scientists are working together more.
Why is that so important?
Well, astronomers really understand stars, galaxies, and how the universe works. They know what kind of data to collect, how to look at it, and what's important. Computer scientists are great at algorithms and analyzing data. They know how to make tools that can go through mountains of data and find the interesting stuff.
So by working together, they can combine their knowledge to make some big discoveries.
Exactly. And I think we're going to see some amazing discoveries in the next few years because of that. It's a really exciting time to be working on this.
It feels like we're on the edge of finding something that could change everything we know about the universe. But let's talk about what it would mean if Dyson spheres really exist. What would it tell us about advanced civilizations and what our future could be?
That's a really interesting and maybe a little scary question. I think it's probably safe to say that any civilization that could build a Dyson sphere would be way different from us. Their history, culture, values, and even how they see the universe would probably be nothing like ours.
So we can't just assume they would think and act the way we do.
Exactly. We need to be open to the idea that they built a Dyson sphere for reasons we can't even imagine.
But we can still make some guesses based on what we know about physics technology and what an advanced civilization might need.
Of course. And one of the most likely reasons is probably just that they need more energy. As civilizations get more advanced, they need more energy, and maybe they reach a point where their planet can't provide enough.
So a Dyson sphere would be a way to solve that problem. But it also means they would be able to control a huge amount of energy, which could be dangerous.
That's true, but it also means they would have to be really good at managing energy and resources, maybe in ways we haven't even thought of yet.
So maybe instead of being afraid, we should be hopeful that maybe we could learn from them about how to manage our own energy and resources better.
I agree. And who knows, maybe they've already figured out how to talk to civilizations that aren't as advanced as them. Maybe they're waiting for us to catch up so we can join the conversation.
That's a cool thought. And it shows that searching for other civilizations isn't just about finding aliens. It's about understanding ourselves and our place in the universe, and maybe even finding other intelligent life to connect with. It's about figuring out what it all means, and feeling like we belong in a universe that can feel pretty empty sometimes.
I think you said that perfectly. Searching for Dyson spheres and other intelligent life is about our own desire to know, to understand, and to connect. It's about figuring out who we are as much as it is about finding other civilizations.
We've been on quite the journey, haven't we? Exploring these Dyson spheres, these megastructures that could totally change how we see advanced civilizations and what they can do. We've talked about the physics, the engineering challenges, the reasons why someone would build one, and the exciting possibility of actually finding one. Now, in this last part, we're going to focus on some of the latest research and what's new in this field. It's really cool how the search for Dyson spheres is going beyond just trying to find a real one.
Yeah, it's becoming more about how advanced civilizations might change the stars around them, shaping their little corner of the universe, you could say.
Exactly. We're kind of changing what we think of when we think of a Dyson sphere, going beyond that classic image of a solid shell and thinking about all sorts of possibilities.
Right, and this new way of thinking is leading to new research, like looking at how a Dyson sphere could affect the star it's built around.
Affect the star? What do you mean?
Imagine a civilization building a Dyson swarm. As they put more and more collectors around the star, less and less starlight reaches the star's surface.
That makes sense. But how would that change the star itself?
That's what researchers are trying to figure out, and it turns out it could have a big impact on the star's structure, how it evolves, and even how long it lives.
So a Dyson sphere wouldn't just be taking energy, it could actually change the star it's built around.
That's one of the really cool things coming out of this research, and it makes you wonder what those civilizations are trying to do. Are they just trying to get energy, or are they messing with their star on purpose to do something else?
Like they're gardening the stars.
Exactly. One of the effects they're studying is that the star surface could cool down. Less starlight means the surface gets cooler. And this is weird, but a cooler star can actually live longer.
That's weird. Wouldn't a star with less energy burn out faster?
Not always. For certain types of stars, especially smaller, cooler ones, a lower surface temperature can actually slow down the nuclear fusion in the core, so the star ages more slowly.
So building a Dyson sphere could make a star live longer. That's crazy. They're not just using the star's energy, they're messing with its life cycle.
It's a pretty wild idea, and it makes you wonder what these civilizations are thinking.
What other effects are they looking at?
Another one is that the star's spectral type could change. Remember, spectral type is how astronomers classify stars based on their temperature and color. A Dyson sphere could make a star look cooler and redder than it normally would.
So a star with a Dyson sphere might look like a different kind of star.
Exactly. And that could mess with our ability to find Dyson spheres. We might be looking for the wrong kind of stars.
That's a little scary. Maybe there are Dyson spheres out there, but we're not seeing them because they're disguised.
That's why it's so important to study these effects. It helps us improve our search methods and understand how Dyson spheres and stars interact.
So we've talked about how these megastructures could change their environment. What else is new in Dyson sphere research?
People are starting to use machine learning to look for them.
Machine learning.
Yeah.
How does that work?
Think about all the data we're getting from telescopes like WISE Gaia and Pan-STARRS. These telescopes are looking at millions of stars, their brightness, color position, everything.
But somewhere in all that data, there might be a few signs of Dyson spheres.
Right. And machine learning is really good at finding those tiny clues in huge amounts of data. They can see patterns that humans might miss.
So we're basically teaching computers to find Dyson spheres.
That's the idea. We teach them what to look for and then let them loose on all that data.
That's really cool. It means we can search way faster and look at way more data than humans ever could.
Exactly. And they're already finding some interesting things.
Have they found any Dyson spheres yet?
Nothing for sure yet, but they have found some things that we need to look at more closely. It's still early days, but machine learning has a lot of potential.
It's like we have a whole new way of seeing the universe now.
That's a great way to put it. And another good thing is that astronomers and computer scientists are working together more.
Why is that important?
Astronomers know all about stars and galaxies, and computer scientists know how to build amazing tools to analyze data. By working together, they can combine their knowledge and make some big discoveries.
So they can use the power of computers to understand the universe better.
Exactly. I think we're going to see some incredible discoveries in the next few years because of this. It's a great time to be working on this.
It feels like we're about to find something that could change how we see the universe. But let's talk about what it would mean if we did find a Dyson sphere. What would it tell us about advanced civilizations, and what could our future be like?
That's a really big question. I think any civilization that could build a Dyson sphere would be so different from us that we might not even be able to understand them.
So we can't assume they would think or act the same way we do.
Right. They might have built a Dyson sphere for reasons we can't even imagine.
But we can still think about what an advanced civilization might need.
Yeah, and they would probably need a lot of energy. As civilizations get more advanced, they need more and more energy, and eventually they might need more than their planet can give them.
So a Dyson sphere would be a way to solve that problem. But it also means they would have a lot of power, which is kind of scary.
That's true, but it also means they would be really good at managing energy and resources, maybe in ways we can't even imagine.
So it's not just about the technology, it's about how they use it and what their values are. Maybe they could teach us something about how to use energy better.
I hope so. And who knows, maybe they're already trying to talk to us, but we just don't understand yet.
That would be amazing. It shows that searching for Dyson spheres is about more than just finding aliens. It's about understanding our place in the universe, and maybe even connecting with other intelligent life. It's a pretty profound thing to think about.
You said it perfectly. It's about asking the big questions and trying to figure out what it all means.
Well, we've covered a lot about Dyson spheres, from the basic idea to some pretty crazy possibilities, and the big philosophical questions they raise. It's been a great deep dive, and I think our listeners have a lot to think about.
I agree. It's been a really interesting conversation.
Thanks for joining us on this journey into the world of Dyson spheres. It's been mind-blowing, to say the least. And remember, if you enjoyed this deep dive, hit that like button, subscribe to our channel, and share it with your friends. We'll be back soon with another fascinating topic, so stay curious and keep exploring.
And keep looking up at the stars. You never know what you might find.